Hi everyone, this is a video on functions and composition for my X203 IA application. I picked this question from Winter 22 exam 2, okay? So we have a function g from a to b and a function f from b to c. We know that f composite g is onto and f is 1 to 1. We want to show that g is onto. So before we start the proof, let us recall what it means for a function to be 1 to 1. So if f from x to y is 1 to 1, then for all, let's say x1, x2 in x, okay, if we have f of x1 equals to f of x2, which means these two outputs are the same, this will only happen if x1 is the same as x2, which means every input has a unique output, okay? Then if a function g from x to y is onto, then for all y in the codomain, we have an x in the domain such that g of x equals to y, which means every element on the codomain has an input in the domain, okay? Then composite function. If h is g composite f, we can write it as, okay, if we have h of x, which is g composite f of x, is nothing but just you tag the output of f as the input of g, okay? So you feed it into the other function. And one thing to note here is that the order of composition matters, okay? Which means if we write g composite f, which means f happens first then g, okay? So in our problem, we have f composite g, okay, which means g happens first then f. And also on for the domain and codomain for composite function, for our problem, if we have f composite g, which means g happens first, it actually maps from a to b first, and then to c, which means it is just like from a to c. So a will be the domain of our composite function, and c will be the codomain of our composite function. Okay. So using these definitions, let us see what we have now. We know that f composite g is onto. So by this definition, okay, for all, remember our codomain now is c. So for all c in c, and remember our domain now is a, there exists an a in a such that f composite g of a is c. I'm just simply replacing y with c, x with a, and g with f composite g. Okay. And again, using the definition of 1 to 1, we know that f is 1 to 1, and the domain of f is b, and the codomain of f is c. Therefore, for b1, b2 in b, if we have f of b1 equals to f of b2, that means b1 equals to b2. Okay, this is an implication. I'm just replacing x with b and f of x with f of b. Okay. So what do we want to show? We want to show that g is onto. Okay, g is onto again by the definition. The domain is a, codomain is b. So for all b in b, there exists an a in a, such that g of a equals to b. Another replication of the definition. Okay, so how do we go about proving onto? Because we want to show that it is true for all b in b, so we will start by letting, okay, let b in b be arbitrary. And we want to show that this is true for all b, regardless of what b you choose. And I'm gonna let c be f of b here, okay? And let me just draw a sketch of what is going on. So we have a, we have b, we have c. We know that f is 1 to 1, so we have b1, b2 maps to c1, c2 by f. And we also know that F composite G is onto, which means let me use another color, say green. For all the output, sorry, for everything in C, we will have some input from A. Okay. So now we want to prove that G is onto, which means for everything in B, have some input from A. And it's not necessarily A1 maps to B1, A2 maps to B2. I'm just showing that everything here must have an input in A. Okay. So because F is 1-to-1, that means this should be unique. Okay, we know that this will be unique. Okay, so by supposition 1, what was our supposition 1, which is this one? F composite G is onto. Let me just copy it down so that we don't have to keep scrolling up. For all C in C, there exists an A in A such that F composite G of A is C. Okay, and because we let C be F of B, we can write it as F composite G of A is F of B. By the definition of composite function over here, we can write it as F of G of A is F of B. And by supposition 2, which is F is 1-to-1, this will be our B1 now, and this will be our B2 now. So G of A equals to B. And because we let B be arbitrary, okay, because B is arbitrary, which means for any B, okay, for all B in B, we can have some A that we can express B in terms of G of A. Okay, so there exists an A in A such that G of A equals to B. And this is exactly what we wanted to prove, right? This over here. Therefore, G is onto exclaim. Okay. So this is a very interesting fact that if we have a composition of functions and the outside function, okay, if we have the outside function, which is F, the one outside, is 1-to-1, and this composite function is onto, then the inside function must be onto. Thank you.